Thank you very much, Dan, and good afternoon to everybody. Just briefly to introduce myself, I work as a program officer in the Basel, Rotterdam and Stockholm conventions, and one of my focal issues is ship recycling and has been for a number of years. So today this webinar is to present the findings of a feasibility study on alternatives to the beaching method of ship recycling. This study was commissioned last year with European funding, and basically, as the title suggests, to look beyond the present-day reality where the majority of the world's ships are recycled using the beaching method to alternative and potentially more environmentally sound methods in the future. Now, this study was undertaken under a wider program operated by the Secretariat, which is the Global Program for Sustainable Ship Recycling. This was developed in 2007, mainly to encourage collaboration between the main actors having any involvement in this industry. What we found was there are a lot of different initiatives by several organizations taking place to improve, for example, worker health and safety and environmental conditions, and the global program was designed to try and bring all of these efforts together so as to avoid duplication of activities. We've successfully undertaken a number of technical capacity building activities under the global program, and organizations that we've collaborated with include the International Maritime Organization, International Labour Organization, and UNIDO, and of course the European Commission. Now, I'm just going to talk about two of these technical capacity building activities today because I want to make sure that we have plenty of time for our main presenter. Basically, the current feasibility study is one of two studies that was commissioned by the European Commission 2 years ago. The first study was a case study looking at models of compliant facilities, but this was specifically in a beaching context. So really what we tried to do there was to take a pragmatic approach to this issue, to recognize that there would be beaching for the foreseeable future, that was the predominant method for recycling ships. But how could we potentially make beaching safer and more environmentally sound? So this case study was developed outlining improvements that should happen at beaching recycling facilities within the short, medium and longer term to upgrade standards. It really complemented the Basel Convention technical guidelines that have been developed 10 years before. On the basis of this case study, we also developed some guidance and training materials which are being offered to facilities in Bangladesh and Pakistan so that they can train not only the workers at beaching facilities but also the competent authorities who assume the regulatory oversight of the industry. Now, the second study that we're actually going to hear about today is a feasibility study, looking beyond what is the current reality and to a future reality which would look towards alternative methods to the beaching method. And it's thought that by employing alternative methods such as pier braking, or otherwise known as alongside braking or slipway or landing, slipway braking or the landing method, that we would be able to have exercise better control over and ensure environmental compliance, and of course also going hand in hand with that is worker health and safety. We did tender for this contract last year, and it was awarded to a Danish environmental consultancy that focuses on the maritime industry, and this consultancy is Lighthouse. With that, I would like to pass over to my colleague from Lighthouse, Mr. Sven Overgaard. Thank you.
Thank you, Susan. Am I there? Thank you, Susan. Can everybody hear me? Yes. Well, I'm from Lighthouse, and for those of you that do not know our company, I will just briefly give a short introduction. Apart from ship recycling, we also do work on ballast water issues, and air emissions, and environments in the Arctic, and waste and oil rigs. Some of our selected references for ship recycling are that we led the World Bank study from 2010 on shipbreaking industry in Bangladesh and Pakistan. We recently did a study for the Dutch and the German development banks, the FMO and the DEG, on global best practices and applicability on ship recycling in Bangladesh. We've also done an assessment of the Danish Environmental Protection Agency, where we did site visits to yachts in Europe and Turkey and China. Of course, we've also done IHM's inventories of hazardous materials, being passports and asbestos surveys. Just briefly to introduce you to ship recycling, I know probably most of you know it, but just to highlight the 4 key methods applied today, and that is pier breaking, which is the ship is berthed at a pier, and you dismantle the ship as a top-down process with highly mechanized facilities. These are the ones we find in China and the Western countries. We have the landing slipway methodology. This is also a top-down process. However, the ship is sailed onto a hard landing. This is the method we see applied in, for instance, Turkey. Other Western countries do use dry docks as well. This is basically you sail the ship into a dry dock in full supports, and you can dismantle the ships in a confined area with minimal risk of discharges to the environment. Finally, we have the beaching method, which uses the tidal barge to sail the ship onto the shore. This less mechanized way of dismantling ships, and the ship is dismantled from stern to bow, about to stern. Sorry. This is the method we see applied in Asia, in the beaching countries of India, Bangladesh, and Pakistan. The top 5 recycling nations in 2011 was they constituted 98% of the world totals, and these are comprised of the beaching nations, India, Bangladesh, and Pakistan, and China as a pier breaking nation, and Turkey finding the slipways. I've included this slide just briefly to give you an idea of the scrap volumes that we talk about here. And I know this is old data, but still gives an indication of what we can expect. And we can see from this figure that somewhere between 10 million gross tonnage a year to 20 million gross tonnage a year we can expect within until 2030, and it just continues. And this area, of course, of interest due to the key impacts that we see in this industry, and especially within the occupational health and safety areas. We see a lot of worker fatalities, injuries, health-related issues from exposure to hazardous materials. Also, of course, the environmental degradation and contamination by hazardous materials of the surroundings. I've included a couple of pictures here from the World Bank study, and we can see that basically the bottom picture, this is basically a hole dug in the sand where all the residual oils, which cannot be sold, are put into. We have on the left a worker with no breathing apparatus, and one of my favorites is the picture on the right, where you can see a number of workers walking barefoot with a large plate of steel, and in the background you can see the mechanical equivalent, which is with a big magnet lifting the same type of steel plate. the workers they're not really fond of that machine because it takes that work. Well, the main regulatory drivers for greening of the industry is, of course, the Hong Kong International Convention for the Safe and Environmentally Sound Recycling of Ships. There's a host of multilateral agreements, in specific the Basel Convention, the Ban Amendment, also the Stockholm Convention and the Montreal Protocol. There's also a number of ILO agreements on workers' rights and occupational safety and health conditions. To get to the crux of the matter, the feasibility study was made to identify cost-effective alternative to the beaching method of ship recycling. And the approach of the study was to first identify the components, what components was an environmentally sound management facility constituted of. Secondly, we estimated the current facilities which is operating and see the level of environmentally sound management and what kind of upgrade they would need to reach a level of a model facility. Thirdly, we did an evaluation of the cost of such an upgrade and a sensitivity analysis of the investments. And then we looked into an incremental implementation schedule and tried to identify feasible locations for model facilities. During the course of the study, we also did consultations with stakeholders such as ship owners and ship recycling yards, which do apply environmentally sound management. So, for the components of the environmentally sound management, we basically used the Hong Kong Convention Facility Guideline and the Basel Convention's Technical Guideline on ship dismantling, and we divided the elements of the components into 4 key areas. And the first area was documentation and identification of hazardous materials. This is a pre-cutting phase. For the cutting phase, there's all the equipment for dismantling activities. And then there's the yard facilities. And that's finally the quality assurance and procedures. For the documentation and identification of hazardous materials, it's basically comprise the inventory of hazardous materials, i.e. that is to identify which hazardous materials is on board the ship. You cannot expect ships today to actually carry an inventory, but this area constitutes work needed to be done to identify that. It's also analysis of materials if one isn't out of what's on board. For the second area, equipment for dismantling activities. These comprise all the equipment to ensure proper handling of hazardous materials, that is personal protection equipment and so forth, and heavy machinery, light equipment, all the equipment that are needed to dismantle the ship. The third area, yard infrastructure and equipment, basically containment installations, impermeable floorings for hazardous materials handling, storage facilities, buildings, spill response equipment, and so forth. The last area was quality assurance and procedures, and these comprise ISO certifications, plans. That could be the ship recycling management plan. That could be the specific ship recycling plan. There's the training of personnel, capacity building schemes, and so forth. So, based on the components, we developed a model facility which comprised differentiating levels of the different components. We then assessed the current level of application of applied equipment, procedures, available infrastructure for pier breaking, slip break facilities, and did an estimate of what upgrade level was needed. The assessment for the assessment, we made 4 baseline facilities, and these are, we can see here, this is an existing pier breaking facility which is non-compliant. We have an existing non-compliant slipway facility, and then there's 2 baselines with no prior dismantling activity. One is the pier breaking, the basic pier, which is to be used for pier breaking, to establishment of a pier breaking from scratch. And then there's the basic harbor area, which is used as a establishment of a landing slipway facility. For these baseline facilities, we estimated for 3 different sizes, that was a 25,000 and 50,000, 100,000 light displacement tonnage capacity. And the last 100,000 light displacement tonnage facility, we did that to be enabled to assess a facility that could dismantle 2 ships at the same time. So this, we also had some general assumptions associated with the baselines. These are basically that we assumed that logical infrastructure was available. We have basic installations, electricity, water, etc. There's access roads to the yard area. We've got waste treatment facilities and disposal facilities in form of, for instance, landfills. Excuse me. There's also a range of specific assumptions associated with the baselines for the existing pier breaking facility. Certain upgrade demand was estimated, and a different one for the slipway facility, and these are associated with the level of equipment needed for an upgrade, personal protection equipment, infrastructure, and so forth. We then looked at the unit price of each of the components, and as we can see on this, it's a little bit difficult, but basically it's divided into first there's an area function that could be a PCB and what is needed. We need airtight drums for the PCB, and the requirement is to minimize the contamination of the environment. The unit is drums, and we need 10. That's the upgrade demand, and for that there's a unit price associated with it. We did that for more than 80 different components. This resulted in a total upgrade cost for the different baselines. If we look at the 100,000 light displacement tonnage facilities, we can see that an upgrade of an existing pier facility is by far the cheapest model to upgrade. The existing slipway and the basic pier and basic harbor area is close to the same area of investments needed. And the cost ranges from $9.5 million US for an existing pier to almost $25 million for basic harbor area. The basic facility, it's developed from scratch. The relationship between different sizes facility is proportional. So this is just made for a ship recycling facility to be able to identify itself with a certain size. So when we look into the distribution of the upgrades, different components, we can see that the majority of the investments are done in yard facilities and hazardous waste handling, as well as in heavy equipment for dismantling activities. And these are more or less the same for all the baseline facilities, and the rest of the areas, quality assurance schemes, training, documentation, and so forth, they comprise less than 10% of the total cost of upgrade or establishment. We also looked into how that would look on a time horizon where we had an incremental implementation schedule of different components, and we used the case study which was done by.
Sven, can you hear me?
Yes.
We're having the same issue as the other day, starting on the same slide. I don't know why.
Starting at the same time. That's very strange.
That's very strange. But so, would you mind? Would you mind starting again, at least on that side, your explanation, because your voice has been cut a few times.
Okay, just on this slide, or do you want me to back up one slide?
Just this slide, I guess.
Okay.
Thank you.
Oh, you're welcome. I hope the sound is it's okay now. We also looked into a implementation schedule on a time horizon, on a 7 years time horizon, using a step-by-step methodology. And basically, we used the method that was applied by Roy Watkinson on the case study, which builds on the Basel Convention technical guidelines. And the first step is a short term, it's up to 1 year, and this is where all the minimal equipment requirements are met. For the second step, that's medium term, within 1 to 3 years, where all the simple and low cost techniques are implemented. And finally, there's long term, 3 to 7 years, where all the infrastructure is improved and the heavy machinery is included. And what we could see that basically for the existing pier and the existing slipway, that there's not much investment needed within the first year, and this doesn't comprise much of the total cost. This is situated in the second and third step mainly. It is the other way around for the basic pier and harbour, which needs to establish a facility from scratch, and this is the reason why we see main investments needed within the first year, because they have no prior operation of dismantling these sites. When we look into what the key components that actually made out the cost investments, we did a sensitivity analysis, and you could see that it's basically the heavy machinery, which is all the cranes and other machinery to lift and move dismantled parts of the ship, which is one of the main components. Originally, we used European market price basis, and for the sensitivity analysis, we used equipment as a low boundary. The other element is all the yard infrastructure. That's more or less the concrete needed for the impermeable flooring, but also to construct offices and storage buildings. Originally, we used mean prices as a basis, and for the sensitivity analysis, we used the low and high price as boundaries, and these we found on a long range of countries in Asia and Turkey. And what we can see is that pier breaking is still by far the most, has the least investment costs associated with it when upgrading. From the low boundary to the baseline, we see a reduction in price of approximately 30 to 33% for all the baselines, and between 20 to 29% from the baseline to the high cost boundary. We also looked into feasible locations for a model facility, and looked into what are the decision-making parameters for identification of such. Part of the scope of this study was to look at the countries which had a history of ship recycling, so that's obviously one decision-making parameter. But we also identified that forced regulation on environmental pollution is of importance. There need to be an access to hazardous waste management facilities. And one of the key decision-making parameters is that there needs to be a strong domestic demand for steel but ready available from other sources, and low wages, as well as a market for ship equipment and consumables. Excuse me. So when we look at the map, we can see that for upgrade to compliant pier braking, we identified some certain facilities in India and China, which could come into consideration. To upgrade a compliant slipway facility, we see that, for instance, existing slipways in Mumbai in India could be of interest. And for the establishment of pier braking, a slipway facility from a basic pier and harbor area with no prior operation, that could basically be any port of infrastructure or ship repair yard. And countries of interest could be Philippines, Indonesia, Vietnam, Thailand, and the beaching nations, Pakistan, Bangladesh, and India. We also did consultations during the course of this study, and we asked the ship owners why choose green recycling. Basically, what they explained us was that they did it mainly to be in compliance with their own environmental policy, thereby, and to minimize the risk of negative publicity. And an interesting aspect was that they didn't find that the added costs as a key barrier. Some of the key challenges they found was that it was difficult for them to identify qualified recycling yards. They also found it difficult to ascertain the consistency between what was actually promised at the yard and the work that was undertaken. And also some of the use of subcontractors in the form of, for instance, green cash buyers, they found it difficult to certain that the transparency was sufficient for them in order to evaluate whether their environmental policy was actually complied with. A part of the study was also to conduct a field mission, and we was invited to China. And in China, beaching is not allowed. It's primarily pier braking which is conducted, and ship recycling is an area that is regulated and enforced. And it's one of the most developed countries with regards to environmentally sound recycling of ships when you look outside the Western countries. We were invited to the Chang'an ship braking yard, which during the last 10-15 years has had several upgrade projects conducted. And they do apply key environmentally sound methodologies, and they have the majority of the procedures are in place, the training are in place, capacity building. They do this picture on the right. You see this is a floating dry dock where they actually take out the rest of the ship when they're finished with the top-down dismantling process. And they explained us that they were actually considering to get on the EU list of compliant facilities, and they highlighted some of the future plans and upgrade requirements for them to come into consideration to be upgrade of the hazardous material, segregation areas. They needed a bit more on the capacity building, needs to upgrade a bit on the heavy machinery as well. And I think with that, I will conclude this presentation, and we can go into questions. Thank you very much for listening.